Okay. Hold on, let me kill all Skype. That was Skype was a bit of an embarrassment last time. There we go. Record my desktop. So,
Seeing if I can make it bigger.
okay. So, thank you all for coming. Is this the first sort of Israeli Ethereum hackathon-like thing? Okay, wonderful. So let's just count the people. 2, 4, 7, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I believe, I actually had one of these in London a couple of weeks ago. The number of people there was around 18. So it's interesting, the London meetup, the presentation had maybe about 2.5 times as many people as the one I did last week over here, but the hackathon here is even slightly bigger. So it's very obviously a very technical, developer-friendly community. So that's always nice. So I guess what I'll present today is how to actually build these so-called Ethereum Dapps that Gav and Jeff and all the rest of us always keep on harping about. So just as an first to start off, how many people here have heard of Ethereum before? Excellent. How many people have programmed some kind of Ethereum contract or application before? Not that many.
Okay.
How many people know what a Patricia tree is?
What?
Patricia tree? Yeah.
Green?
Okay, not that. It's a data structure that's used in Ethereum. I was just getting the level of sort of technical understanding that everyone has. So, Ethereum. So just as an introduction, it's a platform for doing decentralized applications. So the idea is it uses a blockchain. It is a blockchain symbol. It's basically fairly similar to Bitcoin, although with a lot more other parts. But the main distinguishing feature is that there's this programming language, and the idea is that the programming language is sort of tied together with the blockchain in such a way that you could actually use. You could basically write code, and the code could be a currency, it could be a domain name registry, it could be a crowdfunding application, it could be a smart contract, it could be pretty much any kind of decentralized application. And you would take the code and then you would push the code to the blockchain, and people would be able to interact with this code on the blockchain just by sending transactions to it. And basically just as if it was a centralized system, except obviously because it's blockchain based, everything's going to be a lot more expensive. So you want to be pretty careful with operations. So the way that normal people would end up using Ethereum is probably through the Ethereum browser. So the Ethereum browser is the main client that we're going to be pushing. It's called Mist. So this is the proof of concept 6 version of Mist. It's the one that came out about a month ago. So we're going to be releasing proof of concept 7 fairly soon. It just turned out that we had to make quite a number of protocol changes. So because we realized there were a few other things that had to be in the protocol to make it actually friendly to development and scalable. So that's delayed us by a bit, but it's coming, and everything's already finished in Python, and I think we're going to be finished in C++ and Go, Java and JavaScript pretty soon. So Ether browser is a browser. So to prove that it's a browser, actually let's use one of our favorite nice companies. Let's see. It's going to take a while. And okay, it's Microsoft pulled some kind of blue screen of death on us. Let's try Google. There we go. See, Google's better than Microsoft. So it's a browser, but so what makes this different from any other browser? Basically, the idea is that aside from normal websites, you can also use the Ether browser to access Dapps. So Dapps are decentralized applications. So what a decentralized application is that it's basically a web page. Now there are going to be other ways to write decentralized applications. So for example, The browser actually also supports Qt and QML, but it's in the HTML version, a decentralized application is a web page written in HTML. You can have CSS. It also has JavaScript, but there is also a special JavaScript object called ETH, and that JavaScript object actually lets you send transactions to Ethereum and read data from the Ethereum blockchain inside of the web page. So that's basically our model, the model that we'll use for actually writing applications inside of the platform. Also, aside from Ethereum, we're also building up something called Whisper, which is basically like a decentralized messaging system. So there is a proof of concept version of Whisper that's in C++ for about a couple of weeks now. And actually, interestingly enough, just today I saw Gav came up with here in our... Gav is our lead developer. Yeah, so Gav just came up with this Chad Dapp, and you can see it's got HTML, JavaScript, SSH dot and you see there's here's a function. This is the function that you use when you're posting a message, and you can see at the end here it makes a message and ssh.post msg. So SSH is not a secure shell. It's shh as in whisper. So what this does basically is it sends a message to whatever the destination is. In this case, it's not even a destination; it's public.
Like a comment?
Yes.
If you can't see what's on the screen, you can access the Hangout, and there's a link in the comments of the meetup.
Okay, I think I've improved it somewhat. So, ssh.postMS. So you make a message and you post it. And I haven't actually tried running this, but the theory is that first of all, post is that if you press on the button that has the ID entry, it would automatically call the post function, and what the post function would do, oh, there we go, see button, post, it's a button, on click post, and when you press the button, the JavaScript will actually send a Whisper message. So you could mix Whisper, you could mix Ethereum. The general idea is that Ethereum actually lets you sort of have a secure database that's shared between all of the users of the application. So Ethereum in that sense, if you want to have something that uses a database. So in this case, the distinction is if he wants to have something that cares about the order in which messages came, then he wants to use a blockchain. But for things where that doesn't matter, you don't want to use a blockchain. The reason is that the blockchain is expensive and you want to try and use it as little as possible. Sometimes they even it might even make sense to to get a bunch of data and spread the data around off the chain, but put a hash of the data onto the chain. So there's a lot of interesting sort of development paradigms you could use. But for today, the example that we'll sort of be going over is this crowdfunding example. So we talk about doing crowdfunding in 40 lines of code. This is the crowdfunding in 40 lines of code Dapp, now with HTML and JavaScript. Let's see.
Anyone who goes into the Hangout, turn off your speakers and mute your microphone.
Yeah. So what a Dapp is several things. First of all, it's web pages and also a contract. So there's a bunch of languages for writing contracts. Ethereum contracts are the code that actually goes on the blockchain. So this one is a language called Serpent. It's intended to be similar to Python. So Control+. So the idea here is that just to get an overview of how this thing is supposed to work. The idea is that it works the way Kickstarter works. So anyone can set up a campaign, and when you set up a campaign, you choose first of all what address you pay out to. Second, you choose how much you want to raise, and third is you want to set the time limit. Then once you set up the campaign's there, it's registered on the chain. If someone wants to donate to the campaign, then they can send a transaction, and when they send the transaction, the contract actually updates the database and it checks have there been enough donations? Has the campaign reached its goal? If the campaign has reached its goal, then it sends off the money to whatever address the campaign creator wanted the money to be sent off to. Now, if it doesn't reach the goal within the time limit, then everyone gets refunded. So I'll go through the code, but then I think the thing that we'll do is we'll probably end up writing something together. So just to go through the way this works. So first of all, the way a lot of these contracts work is that they basically sort of have APIs. So in this one, you have three. So the API for this contract has three commands. It has a campaign for starting a campaign, for contributing to a campaign, and just asking for a progress report in case another contract wants to ask the contract how a campaign is doing. So, and then over here, just in the comments, I defined how the storage is going to work. So storage is like a key value database. Every contract has the ability to access its key value database. This all still on the blockchain, by the way. So campaigns. So every campaign is stored in this format where the first field is the creator. So the address that created the campaign. Actually, I don't think it's the creator. No, it's not the creator, it's the recipient. So initially the creator always had to be the recipient, but I changed that around a bit. Then after that you have the goal, then the timestamp that the campaign has to end at, the deadline. Then you have the counter of how much has already been contributed. So it's like a running counter of, raising $10,000, but we're raising 10,000 Ether, we've only raised 5730. So this is where 5730 would go. This is just a point, and then after that we're going to record all the contributions. And we'll record them in this pattern. 2i plus 5, plus 5 and plus 6 are the first, then plus 7 plus 8, then plus 9 plus 10. And if we want to append one to the list, we store the location where we append to the list in plus 3. So why do we want to record all the contributors? Now it's not just it's not because we care about the information for posterity or something like that. If we do that, then the correct thing to do actually is if you just want to log that something has happened, we're adding a special log opcode in POC7, and you'll be able to just log the data. So that just logs a little entry in the blockchain. It's like pure proof of publication, minimal inefficiency. And the idea is that log is the thing that dApps will be able to watch for. So light clients, for example, could very easily watch for logs. So but the reason why I want to do this is because if the whole thing doesn't work out in time, then we want to refund everyone. So start a campaign. What do we do? First of all, so the way that we distinguish between these different APIs is that we.
Can I ask
yes.
Stupid questions? In terms of the size of the data, that is.
Keys and values are 32 bytes. Thank you.
Okay, so the addresses here are limited.
Yeah. So by address we mean an Ethereum address, so 20 bytes. Now, if you want to put your actual address in, that's one of those things that you don't want to put on the blockchain. You want to spread around, and if you really care, you can put a hash of it on, or realistically just log it. So, anyway, so start a campaign, data, 0 ID, recipient, goal, time limit. So the way that these different APIs are distinguished from each other, so if you send a transaction, in this case, transactions have data, so you would set the first data field to 0. If the first data field is 0, then, if the first data field of the message is 0, so by the way, a message could be two things. A message can be a transaction, or contracts also have the ability to send messages. So you could actually have a contract inside of Ethereum. You could have another dApp, and that dApp would talk to this dApp. So if you imagine some kind of crazy decentralized organization, and that decentralized organization suddenly wants to crowdfund something, you can use this contract too. So anyway, so first of all, what we do is we're gonna pick. So after 0, you would choose an ID. So the ID would just be some random number, and it would check. So first of all, the contract enforces the rule that IDs have to be a specific multiple of 2 to the 128. Because the thing we don't want people doing is we don't want people starting campaigns, and those campaigns end up being stored in the middle of other campaigns. So we do that. Now, if there's something already registered there, then we return 0. If we don't return 0, then all we're going to do is we're just going to store all this data, right? We're going to store the campaign recipient, so that's the second argument. The third argument is the goal. The fourth argument now over here, I have it ask for the deadline, or for the time limit, but I'm going to turn the time limit into the deadline. And finally, add +3, the index of the next contribution. And then just in case it's a contract creating this, I'm going to return the ID just in case. I actually don't need to do this anymore. So next step, contribute to a campaign. So if you have a campaign, you have the campaign's ID. Then you would set the first of all, transform the ID, multiply by 2 to the 128, so it's sort of nice and aligned. Then it would update the contribution total. So over here, the total contributed. So you notice that we're storing the total amount that's been contributed to every campaign here. So what we're going to do is we're going to update it over here. See, we're taking the value that already exists, then we're adding the amount of ether on the message, and then we're just setting it. Now, to record a new contribution. So this is just a matter of, remember over here in the contract, the thing that we were doing is we were recording all the contributions. So what we're going to do is we're going to grab the index that we're supposed to be storing it at, store the data, and update the index, just shift it right by 2 so we can store something else at a different location. Now over here, what we have is it's a pretty obvious check. So anyone care to guess what this line of code does?
If enough is completed,
well, actually, yes, correct. If enough money has been collected. So ID plus 1, you notice ID plus 1 is supposed to be the goal over here. So, yeah, so, yeah, exactly, it collects the money. So, the contract collected all the money already, so the contract is actually the thing that's holding the ether right now, right? It's not the users. Like, there's no ability to pull ether from people's accounts, fortunately. This is, we respect private property here. So, the ether is in the contract, so if enough has been contributed, then what we do is we send the amount that's been contributed to the intended recipient, and then we just run through the contract and we just clear out everything. So we just run a big loop and we just clear out the storage because, this is a sustainability place. We want to be environmentally friendly. We don't want to pollute the database.
Can you send negative amount of ether?
No. So, anyway, expired. So this is the other check we want to have. We want to check, obviously, if the campaign is expired. So we check the block timestamp, the current block timestamp against the deadline, and if it is, then anyone want to guess what this nice little loop does? No, it's not just so these two lines do the cleaning, but why do we need this line?
Send the funds to the person fundraising.
Exactly. Refund. Okay.
And refund.
Yeah, progress before. Okay. So that's it. So so this thing, because it's an actual Dapp, so I'm just gonna go ahead and show it in action. Oops, sorry. Not HTML. So I'm just gonna create some address. The standard address that I use is crow, by the way. Oh, sorry, not PyBTC, so I want PyEth client. So, then for the goal, let's say I want 10,000, and for the time limit, how many days do we want? Pick a number that's not 0.
5.
Someone said 5, someone said 7, so I'm gonna compromise and go with 9. Okay, fine, compromise 44. So now what I'm doing is I'm waiting for a confirmation, and I'm gonna start mining here because it's a local network. So in Ethereum, the block time is 12 seconds. So basically, all we have to do is just wait for this whole thing to confirm. Hopefully it will soon. Ta-da! So what we have here is, we notice that the transaction it confirmed, and we have now have a link where we can go check out our campaign. So the campaign, you notice, is pretty boring, but over here you see it's got a time left, Now what we're gonna do is we're gonna be cheap bastards, and we're going to contribute 1 ether. Actually, it's only 1 way, which is just 10 to the minus 18 ether. So
1 way?
Yes.
It's like gas?
No. So way is the tiniest unit of ether. It's like our version of a Satoshi, named after Wei Dai. So waiting for confirmation. So we sent this 1 way. There's a transaction.
It has access to your wallet because you're in the browser.
Yes, exactly. So later on, what we're actually going to implement is going to implement a permission system. So the browser will actually be able to give you a text box, and it'll say you're sending a message, and it's going to have these consequences. Do you say yes or no? So once it got confirmed, you notice it says contribution sent, and we can try to contribute some more. So let's say I'm a really rich guy, so I'm going to donate 9996 way. Contribute again. You notice it can actually you can actually pull stuff in real time. So one of the things that this contract is doing is it's actually pulling every second to check if it confirmed. That's actually not the really nice way to do it. It's just that Mist happened to be broken at the time that I was doing this, so I think it should be fine now. So there we go, contribution sent. Now guess what happens if we're gonna send 3 more way this contract's way. Wait for confirmation.
What would happen if you didn't wait for confirmation? You sent 2 of them.
Oh, that's fine. They'll both transactions will get confirmed eventually.
Are you doing this on the test network?
This is it's a private test net.
Private test.
I think it probably could. I probably could connect it to the POC6 testnet if I wanted to, but it's just simpler this way. So 27. So one of the problems with the block time is it's supposed to be 6 seconds, but actually I think the difficulty starts off at 2 to the 17, and 2 to the 17 over 7K is about 18 seconds. So sometimes it gets low, and there we go. Basically it's done. So that just goes through the entire process. But then you notice that I actually only showed you one part of the code, right? I showed you the part of the code that's on the blockchain. So the other part of the code that I need to show you is the HTML, the JavaScript. So for HTML, it's just pretty boring web page. Now, unfortunately, if I was doing a more proper project, I would probably write this whole thing in Jade, because Jade is much better than HTML. But
Jade?
It's a thing that compiles down to HTML. It's really nice. Here, actually, this is something that everyone should know about, so I'll provide an example right now. Let's see. See, it's really nice like that. This is Jade. It's nice. It's
like slim.
I don't know. I sort of think of it as the Python of markup languages. Avoid all the ugly brackets. It just works. So anyway, and it works really nicely with Angular.js as well, which is what I'm using here. This is just my multi-sig wallet thing that I invented, that I came up with like about 1.5 years ago. Yeah, I didn't invent multi-sig wallets, I just wrote one. Anyway, HTML is boring. You all know HTML, hopefully. Anyone doesn't know HTML? Okay. Oh wow, everyone knows HTML. It's,
I don't know HTML, but I'm not a programmer. So
okay. Do you know XML?
I don't even know what XML is.
Okay, I don't really know XML that much, so.
The great Facebook ad. I
Cool.
know how to translate nerd to English. That's like my profession.
Cool. Can you translate English to nerd?
It's a one-way street.
01100101 was that? I think that's the letter E.
That's English to...
Okay. So the interesting part is the JavaScript. So for the JavaScript, you notice we had 2 views, right? We had the view for creating a campaign, and we had the view for contributing to a campaign. So, once again, if I was doing this properly, I would have used Angular.js, but this is a quick and dirty job. So, first of all, we're going to put up the crowdfunding address. I'm not even. Edit profile preferences.
Campaign.js or campaign setup.js?
this is common.js, so there's a bunch of files that are important here. Okay. So if you go in, so if you want to follow this on your own, by yourself, what you want to do is you go into this Ethereum Dapp bin, and you want campaign_setup.j. Or actually, no, not that yet. Load up campaign setup.js, but the other one you want is common.js. Common.js, the file in this Dapp, as opposed to common.js, the framework that lets you write Node and browser stuff at the same time. Oh, really? Okay, that's me being stupid with Git. Hold on. Git is fun. Okay, so let's just wait for the screen. There we go. So anyway, so what we have here is we have the crowdfunding address. Then below that, we have this nice function that just timeify just translates the number of seconds into this nice view that you saw that tells you, how many days, hours, and minutes are left in the. So here what we have is we have something that looks a bit ugly at size 22. I wonder if I can make it less ugly by going a bit, by compromising a bit and say making it 19. There we go, perfect compromise. So get details is a function for getting the details about a particular ID. So first of all, what we're going to do is we're going to just so this is something that's also going to, I think it's already improved, we're just using an older POC6 API, but there's a function called eth.stateAdd. The point of eth.stateAdd is it's a callback function. It just gets you the information at some it gets you the storage at some particular key of some particular address. So first you have crowdfunding address, then over here what we're doing is we're doing a bit of an ugly hack to construct a hex number. So you notice over here that what we're trying to do is, hold on, where is this? Where is the .sc file?
Is that the 128 padding?
Yeah, it's the one, right, the 128, yeah, exactly, it's the 128 padding. So, going back to the .sc, so what we want to have is we want to have these four things, right? And those are the variables that we care about. So what we're going to do is we're going to grab the thing plus 0, that's the recipient. We're going to grab the thing plus 1, that's the goal. Grab the thing plus 2, that's the deadline. And we're going to grab the thing plus 4, and that's the current number of contributions. So then we're going to do eth.from ASCII in order to convert them back into normal. In this case, substitute 24 just trims it down from 64 characters to 40 characters because it's an address, converts it to a decimal. Here we're going to convert the value to a decimal, but what we're also going to do is we're going to subtract the current time, because what we care about is the time left. The blockchain stores the deadline, so basic math, deadline minus now equals remaining time. Yay, we know math. Contributed is the amount that's been contributed to the campaign. So far we converted to decimal. So in case you want to know, the APIs are getting better and better for this. So if you go to wiki, and you go a bit on the right, you will see something you see in the Dapp development section, JavaScript API, and in the JavaScript API you'll have all you need to know about all this stuff, blah blah blah. So, going back here, so that's all we need for common.js. Now, campaign setup.js.
Can you explain all this padding to 32 characters?
Oh, sure. So that's just something, padding to 32, that's just something that's necessary in order to format the values correctly for the API. That's something that's going to disappear. So it's going to become much more intuitive soon. So, anyway, back to
in case of recipient, you're taking 24 characters up.
So that's because So everything in an Ethereum contract, all the values are 32 bytes, right? Addresses are 20 bytes. 32 bytes converted to hex gives you 64 bytes. Address is 20 converted to hex gives you 40. We only care about the last 40 of the 64. Therefore, we cut off the first 24. So, over here, we generate a new ID. Over here, we initiate. So initiating is the function that actually starts the campaign. So we see is we generate an ID, then we take the value in the little time limit box. So if we just go back to here, you remember that there was a little time limit box, and back then we said 44 days. How many days do we want this time?
2 days.
2 days. Okay, we got 2 days, so I'm going to compromise and I'm going to say 800 days. What goal do we want? I'm going to compromise on the null set and I'm going to say 130. And the address, I'm going to say we'll take the crow again. Except we're going to be really, really mean, make it unspendable, and we're going to convert the C into a D. So what happens when we create? So first of all, campaign setup.html. So onClick, you see onClick equals initiate. So we go to initiate, we generate ID, then we take the time limit box. From the time limit box, we get the number of days multiplied by the number of seconds in a day, which is the constant everyone should memorize. Get the time limit, then the way value. Oh cool, it actually is ether, it's not way. Okay, so we weren't that cheap. See, we're adding on 18 zeros. Then eth.transact is the thing that actually makes a transaction. So eth.transact takes a bunch of parameters from eth.key. That part's actually going to be removed, by the way. Dapps are not going to have access to your private key directly. Value 0. So value 0 because there's no reason why we wants to donate money to the crowdfunding campaign contract. To the crowdfunding address. Now for data, what we're going to do is we're going to format all the arguments. So we're going to take all the arguments that we want. We're going to pad each of them to 32 bytes. So we're going to pad, first of all, we're going to pad 0. 0 is the if you remember over here, hold on, remember where? I remember over here, it checks if the first data field is 0, right? So we want 0 to start a campaign. So we pad that to 0, then we do the ID, then we do the address, then we do the goal, and then we do the time limit. For gas, we just set some value. For gas price, generally 1 sabo is pretty standard. 1 sabo is a millionth of an ether. Then,
What is the gas price?
It's 1 over a million ether. So the gas price is the amount that you're paying per computational step in the transaction. So when a transaction gets processed in the Ethereum network, you have to pay for every computational step.
I think it's like a service. It's a service.
Basically, yeah.
For the system.
Yeah. Yeah. So the fee is not something that we're charging, right? Nobody, like, the service fee is something that's charged by the network, by miners, basically. So campaign address inner text, waiting for confirmation. So when we actually click create, you notice I created this really nice thing here. So the way that works is I'm going to set to waiting for confirmation, and then I'm just gonna, and then what update does is update is this crazy pseudo recursive function that calls itself in a timeout, and all it does is it keeps on adding a dot to this guy every second until it sees that it checks the blockchain and it sees that the recipient is not 0, which means that the recipient has actually been set, in which case it sets the address. So superfunder.eth is not an actual address, but you know, you could fit whatever you want. I kind of cleverly put the craft to be, you know, what I want it to be anyway. So
what happens if the transaction fails?
So the transaction, I guess how. So if, I guess it's the
already is a contract of the.
Yeah. So first of all, so the contract is already on the blockchain, right? So the Dapp kind of assumes that the contract exists at that address. Then if you send that transaction, there's 2 ways the transaction could fail. Several ways. One is that the transaction is signed incorrectly. That should not happen because your Ethereum client should sign it correctly. Another way is if you don't have enough money to pay for the transaction, in which case, you know, your client should give you a big flashy red error eventually. You know, please buy more ether for the good of humanity. The third way is that the transaction just gets broadcasted onto the network, but for some reason, every single miner just decides we're not going to include it. Theoretically could happen, and if that happens, then your transaction never gets included. So, in theory, I think the client should probably keep on trying sending the transaction again and again, and it should succeed eventually. It might flash, if it doesn't succeed after like 5 minutes, it might flash an error message. So,
can you get the result, like the return value?
Yeah, so can you get the return value from the transaction? I don't believe you can, at least not within the Dapp. So
the function here is the success function, or is it a complete function, or the error?
So what we have here is we have ETH.transact, right? It sends a transaction, then let's call this update thing, right? So the transaction was sent here, right? In the ETH.transact method. Then the update function is just a loop. It keeps on checking whether or not the campaign was registered. Once the transaction gets into a block, it's guaranteed that the campaign will be registered. So therefore, once that happens, the campaign is going to end up being so the storage field. So get details, you notice, is the method for grabbing the details about a campaign. This just grabs some data from storage. The data in the storage is not going to be 0, so it sets the campaign and it stops recursing. So, that's basically all it is. That's basically all it is on JavaScript. It's just a thing that creates a transaction and then starts this crazy loop that just repeatedly. Oh, by the way, this stuff is debugging. You don't need it. So that's one part.
So the return value and the contract side is only for other contracts?
Exactly. The return value is only for other contracts. Now, if you in a contract want to make some kind of signal that Dax will be able to read,
you do it on the storage.
well, you can do it on the storage, or you can use the log opcode. Yes, that's a POC7 feature. So the log opcode is a way of just logging an event, and it goes on the blockchain, but it doesn't pollute the state. It doesn't pollute the storage. So it's just noted as a sort of historical event. It's proof of publication. So the other thing that we want is the JavaScript file for the actual campaign. So here,
is there a plan to make these JavaScript promises that you don't
yes,
have to loop?
yes, there are actually going to be promises that, as I was saying, the POC7 API is considerably nicer. So ID, first of all, so what we have here, first of all, you notice is it's going to create an address where it's campaign.html followed by a hash followed by the ID. So here what we grab is we grab the window location hash. Without the hash symbol, we grab out the ID, check if the value is valid. Then we do a get details. Then, oh, right, so this is the function for contributing, right? Before we contribute, we don't do anything. So first of all, we get the details about what the campaign is. This is just to make sure sort of that the campaign is there. And we make a transaction. Now over here, we remember what are the arguments for. Now, if you want to make a transaction to contribute to a campaign, you need 2 arguments. The first argument is just a number 1 to register the fact that this is a transaction to claim stuff or to contribute to campaign, not to start a campaign. And what's the other argument when you're contributing to a contract?
The ID.
Exactly, the ID. So ETH.transact, make a transaction. Now it does this waiting for confirmation thing, and it runs update, and update is a stupid pseudo-recursive method just the same way, except there's another feature, which is if the recipient is 0, meaning if the campaign is over. So if the campaign is over, everything gets erased. Then we do basically clear out the entire space. Now, over here, what we're doing is we're checking get details, and you notice we store a variable called curcontrib. It's the amount that's already been contributed to the campaign. And the other thing that we do is we have this loop where we check if the amount that's been contributed to the campaign is the same as the amount that was before, as the amount before making a transaction. Then we just add a dot to the progress, and we recurse it in after 1,000 milliseconds. Now, if we notice that the amounts contributed to the campaign has increased, then we say contribution set. Now, The code as it's written actually has one flaw in it. Anyone want to point out what that flaw is?
If someone else sent it, you
Correct.
you refer to your sender.
Correct. So the only way to solve that is basically through
What's the flaw?
The flaw is that if someone else contributes to a campaign at the same time that you do, then even if your transaction fails, it'll look like it got sent because the balance increases. So, anyone want to guess how we solve the problem without polluting storage?
You add your sender ID when you send it, and you can check it later.
So the key solution involves the log opcode. So you just log an event, and on the event you register yourself as the sender, and you could have a transaction ID be in the message.data field. That works too. So you have the sender, you have the recipient, and you have.
Don't you keep it anyway for the refund? So you must have it
Right.
somewhere.
Yes, you do keep it for the yes. Right, you could keep it for the refund. So what this thing could do is it actually could just check through the entire list of senders, or at least it could actually, that's correct. It could check through the list of new senders, and it could see if any of them is yourself. So that actually is valid, and would do it without the log opcode. But you know, the log opcode might be a bit nicer. Actually, whoa. We.
It's live broadcast right here.
Yes. The other thing is though is that the one case where that fails is that if you have a campaign that's almost successful and then the campaign succeeds, then because everything gets deleted all at once, the Dapp actually won't be able to detect it. So two ways to fix that. One way is you don't erase everything and you don't send by default. Or you don't erase everything, you don't send immediately. Instead, you require the creator of the campaign to actually send a transaction to claim everything once everything's been sent. That's one option. Another option is use the log opcode. So,
Something basic that I don't understand.
Mhm.
Like when the contract continues to grow, right? All the information is left in the blockchain, right? Even if it clears it afterwards, I can go back and then see whether I've inserted it before, because the blockchain doesn't clear, right?
So inside of your Dapp, you could check the historical state instead of the current state. Eventually, in Ethereum 1.0, the initial version of the client, it's going to be a relatively simple store everything sort of set up, right? But over time, like over basically 2015, we're going to roll in clients that don't that basically try and forget like past versions of the blockchain state after some amount of time, probably even maybe like a few hours or days or something. So at that point, looking at historical state is going to be pretty expensive, it's going to be like expensive in the sense that there's going to be a bit more lag to it and so forth. So
the current API doesn't allow me to.
I think it does allow you to go arbitrarily back. Right. Yes.
Storage key value, or is
Yes.
it like
It's key value. Actually, and the other thing is though is that if you make a transaction and your transaction actually pushes the contract over the edge, so it pushes it to the point where the campaign is finished, then you notice that the way the contract is written, it actually ends up recording your contribution, but it ends up deleting it immediately. So the storage actually never gets published, right? So that's just one of the reasons why log might be useful here.
Can you explain the log opcode?
Sure.
What exactly that?
So the log opcode just registers an event in the blockchain inside of a special tree. It registers it as part of the transaction tree, but that's a tree that it just gets stored as part of that block. So it becomes sort of part of history without actually being part of the current state. And the idea is that once the lock is made, any light client will be able to very easily just sort of go back through the chain and will be able to check it'll be able to check to see that there's a log. It has a little chain of hashes going up to the block header, so some message was actually registered. So
like a receipt for the block?
basically, yeah, you can think of it as a receipt.
Like audit?
Huh?
Like audit?
It's not really for auditing. It's for letting people get proofs that certain things happen quickly, and then if you want to audit, like the way that you would audit is you could verify specific parts of the blockchain. You could check things against each other. So anyway.
What do you mean it's not part of the state?
So the state.
It's part of the blockchain, right?
Yes, the blockchain and the state are two different things. So the state is the current set of all account balances and contract storage, right? It's like a tree. And then there's also the blockchain, and the blockchain contains blocks. Every block contains a transaction tree and also contains a tree for like receipts. And receipts are basically, they're just like records of events that we care about that got recorded by transactions. So like there's a receipt for state changes, there's going to be a way we're creating a receipt for a log. And so that's all a tree that all gets hashed, it all ultimately gets into a block, but it doesn't sort of update and keep up with the current block forever. And also there's no requirements for any node to have the to keep storing it. There's no requirement for any node to keep storing any logs, right? You just sort of assume that a few nodes somewhere will, and if you care about a log, at least you will.
Okay, so just on that point, so a contract has a state, right? So when you said that the contract kills its state, right? It means that this state is killed, and there are no copies of that in the past history.
No, it means
copies of.
So there are going to be copies of it in the past.
Carried on to the next one.
Yeah, but it's not going to be carried on to the next block. And then starting from the next block, it's not going to be encoded.
And that's to avoid the exponential growth of the blockchain?
Yeah, so, well, the idea is that you want to make the growth of the blockchain less exponential if we can. So, actually, the other thing we're adding in POC7 is we're adding an incentive to clear storage. So, like, before it was just an altruism thing, but now you get a refund of 100 gas for doing it. So, yeah, that's basically it. So, I think actually just to make things more interesting, I think the other thing we probably could do is we could probably even just write a very simple Dapp from scratch and see how that works out. So, 2 options, or 3 options: name registry, currency, some other idea you have. Other? What else? Not
instead of registry of a single thing,
yes.
Maybe we can register a family tree. That is, that everyone can say that if we are related, then we have some kind of a registry that of the two of us need a connection.
Sure.
And build some kind of a registry of lineage.
A registry of connections. Okay.
I have another idea. So for me, it's important to know the complexity of specific contract. I want to start with a very simple contract like subcurrency, like Hello World of Ethereum. But I want to create contract myself with Alidero and try to send money to somebody else.
Yeah. If anyone wants to join on right now, if anyone wants to try join and be on the same network, we could actually try that. Actually, I wonder. I mean, one option. So, does everyone have the? Okay, you have L0. Does anyone have Mist installed, the POC6 version of Mist? So the problem is we have POC6 clients and POC7 clients. And
is there a link?
Mist is already POC7?
There is a POC7 version in progress. Here, hold on.
Be able to find it and give up, right?
I mean, so if you want to, if you want to sacrifice this idea of sending between different computers, and the whole thing just becomes much easier.
We can do it.
Okay. Thanks. So, go Ethereum.
Go Ethereum.
No Mist. So there's a wiki in the wiki. In the wiki, there's a page on building Ethereum.
Do we need to compile mist from source or?
I believe there's I think you probably would have to. So so just like I think what you should be able to do is just clone one of them. Is clone yeah, do the automatic install script.
It's for 1404.
Mm.
You okay?
Yeah. And if you want to actually, if you want to try the POC6 version of L0, you could get that too. Hmm.
Any recommendations?
Building for Linux install, huh? I actually...
You're on Linux?
I run 1404, and the reason why I installed 1404, even at the cost of accidentally deleting $1,000 worth of stored Jcoin, is because... is because Ethereum, the clients like installed badly on 1310 and so forth, so...
Okay.
Is it easy to do all the install, all the development on Amazon EC2?
Okay.
Do you have a way? Do you have a way of like SSHing into a GUI?
That's because I installed it and I don't have the GUI. It was not successful.
Right. Without a GUI, all you can do is contracts. And if you want to do so, if all you care about is contracts, then you could actually you'd want to use the Python client. The Python client is way easier to install. It's and it's very easy to work with, and you have that. I think there's a separate tutorial for it.
צבי, יכול להיות שעם הקונטיינר שלך? עם זה שעשית?
What clients do people have installed? I'm just wondering.
I have LS0.
LS0 POC7?
Yeah.
Okay, just use that. If you guys manage to connect to the same network, then awesome. I'll just be on a different network and I'll be using POC6 Mist. It doesn't really matter. So anyway.
Do we connect to POC-7sdev.com?
Yep. If you have a POC6 client, feel free to connect to POC6 Dev. I will warn you, it might take a while to sync up, but actually no, it might not. I think POC7 is pretty, L0 is really fast syncing.
Each POC will change the initial initial block seal, so it will start on a different blockchain.
Yeah.
And how maybe I missed it, but how the initial synchronization works, since you set it Ethereum protocol actually tries to forget its history.
Right. So the idea is that you would just like when you start up your client, it would ask you for a recent block hash. You would put in the block hash. Then from the block hash, it would sort of recursively it would ask the network for data. It would like make a reverse hash lookup query, and it would sort of build up every single tree level by level. And then once you have the full state, then you just go from there.
So actually, I don't have the one hash like Bitcoin. The zero hash I'm going from bottom.
I mean, you could. So right now, when we have archive nodes, you'll be able to go from zero hash from the Genesis going up, but. Just realistically speaking, like the approach of starting from the middle is just much faster.
Yeah, of course.
So
actually, so you need the initial hash to get the. You need to get this right, and then
exactly. And the initial hash you just get off of like whatever the equivalent of blockchain that it was going to be. I mean, actually we have a bunch of blockchain.infos. I think we run one ourselves. There we go. There's ours. See, Ethereum Blockchain Explorer, the official one. Uncles. See, Ethereum is family friendly. We have uncles, and we have parents. But Bitcoin also has parents. But Bitcoin believes in this. Believes in the one-child policy. Actually, Ethereum also believes in the one-child policy. We just don't quite believe in the one-parent policy. So anyway, everyone have their clients? I guess we can start. So, see, what did we settle? Actually, what do we want to do for the Dapp? So one option is just like a way of registering connections between people. Is one idea. Anything else?
Currency is also good.
Currency is also good. Okay.
Is it already available?
Huh?
Get an external fee, like a weather, like a crop insurance contract or something like that?
External feeds. I'm not sure. I mean, there are external feeds. The challenge is verifying them.
Yeah, or taking about 20 and taking the mean value.
Yeah, you can, right? Yeah, you can do that. But the problem is that most data feeds in the real world, they don't have like nice elliptic curve signatures attached to every data field, so you can't.
So there's a lot of dirty work to clean it.
So right now, if Bitstamp maintains a data feed for the price of BTC and USD, but if you want that to be useful in Ethereum, then I think you'll have to do one of two things. One is you'll have to have some other company or some other entity will have to basically take the Bitstamp data field, and they'll have to run like a sort of pass-through feed, and the pass-through feed will just sort of add elliptic curve signatures to all the data, and then maybe trust the signatures. The problem with that, though, is that you're adding an entity that's it's less reputable. People trust that entity less than they trust Bitstamp. So the other approach is, this is incredibly ugly and incredibly expensive, but you basically take the webpage got transmitted to you through HTTPS, take the HTTPS packet, shove it into Ethereum, verify it inside Ethereum. So, as I was saying, extremely expensive, but actually, no, it's actually not prohibitive. There are ways that you could actually make that work. So even if the web page is, the web page is obviously going to be like many kilobytes expensive, but so the way you do it is it's a contract. The contract has multiple. Let's say it's a contract between two parties. Then one party, what the first party is going to do is the first party will say, here I'm submitting a transaction and I want to claim whatever I'm entitled to. And then, by the way, here is what I say the data is. No signatures, just here it is, I say so. Once that happens, there's a waiting period. During that waiting period, the other party can submit a challenge. Then, if they submit a challenge, only then is the first party required to actually submit the entire data, and have the blockchain verify the whole thing. Verifying the whole thing might take a really stupid transaction fee. It might be like $30, right? But
then you create sort of data
but the
escrow,
but the idea is it's like an escrow thing. But the idea is that the Ethereum contract and the ability to verify HTTPS only acts basically as a threat. It doesn't actually happen. It acts as an incentive for the first person not to lie, because if the first person lies, then the second person will challenge, and the first person won't be able to corroborate the lie, and the first person will lose a pretty huge deposit. See, so this is one of the sort of tricks that you can do in crypto economics, makes a whole bunch of stuff much cleaner. So,
You need a break?
Yeah, they
No,
want
I'm
to take a
fine.
break and have
Alternatively, we could try talking softer. Sure. Actually, we'll just call it graph. We'll be generic. So, first thing that we need 3 files. Actually, we might need. Are there any other files that we might want to have?
CSS.
Maybe, but I don't care about CSS. So, first off, we have to figure out what we want to do. So, as I understand it, the idea is that we have accounts, or accounts are controlled by people, and we want the ability for a person to be able to register into the contract. But by the way, I'm related to this person, right? So in a way, it's basically kind of like a reputation system, except it's just a 0-1 binary thing. So then, the other thing we might want is we might want the ability for other contracts to query, are these 2 people related? So how about we'll do both of those. So first of all, we want a model of how in storage are we going to store whether or not there exists a connection of A and B. One approach is to just take the SHA-3 of A concatenate B. So we'll probably do that. So the other thing is, what messages do we want? So we want our API to have 2 pieces. One API is for saying I'm connected to this guy. The other API is for asking, are these 2 connected? So we'll do that first thing. Comments from inventory so far. A later version of Serpent, by the way, that I'm going to push out relatively soon, is going to replace this whole machine on data thing with a more sort of intuitive function-based mechanism. So watch out for that. It'll be mostly compatible with upcoming Solidity API. So it's actually very simple. Just watch one line. So what does this do? So first of all, what we're going to do is we're going to take the sender of the message, and we're going to take the person they want to register a connection to. Then we're going to make an ID out of them, and the way you make an ID out of them is you basically just hash them together. Then, once we hash them together over here, so the way we're doing it is we're just saying SHA-3 of this array, and this array has a length 2. If you've ever tried to implement compilers for C++ or something like that, you'll kind of intuitively understand why we also have to specify an array for the why we have to specify a length for the array here. It's because it's like these aren't objects; they're just pointers, right? So that gives you an index. Then we're going to set the contract storage at that index to 1. Simple. Anyone not following here?
It's not a Python notation.
No, it's not Python, but it's a language that's designed to be very similar to Python.
No, I'm talking specifically, not about Serpent, but
yes.
about square brackets without the array.
What do you
Inside
mean?
SHA-3, you have the square brackets, just square brackets.
Yeah.
So like a concatenation.
So this is basically
Is it
no.
a
It's a
list?
So what we're doing here is we're just taking the SHA-3 of an array,
Oh, okay.
right? We're taking of an array, and we're saying to take 2 elements from it. So, look, there are several things you could do. You could say SHA-3 cow, or you could say SHA-3. Actually, hold on. Let me just check the definition of SHA-3 in the Serpent compiler. 1 sec. The nice thing about the Serpent compiler is the way it's written is it's just a bunch of rewrite. The main part is just a bunch of rewrite rules, so you can actually extend the Serpent compiler with your own functions if you want. Okay, there we go. See? So, yeah, all we need is 2 elements and it expands it. Now, the other thing that we want is we want the ability to check for a connection. We can also do this as a one-liner, by the way. Just watch.
We may want to put the other edge as well, the other direction.
So, relationships here are one directional. It's unrequited love contract. So anyway. Anyone not follow that? Okay, everyone followed it. Nice, no explanation.
0 is the default value.
Yes. Oh god. And there's a bit of a black swan.
What?
The fact that all these files are, I'm doing Vim not in sudo mode. Okay, let's see if I can do some clever trickery here. This is also a Linux tutorial. Done. Magic. Okay. So we have a contract. Now the other thing we want to write is we want to write an HTML page. So what do we want? I guess we want 2 text boxes. You know what I'm gonna do? I really hate writing HTML, so I'm just gonna copy this. Oh right.
You should use Emmet.
Use what?
Emmet.
Okay, it's a Vim thing for HTML. Cool. I'll look into it. Thanks.
What's the thing?
Emmet.
So all we really need is just 2, and we need a button. The button we have over here. Ta-da! I should have picked a really simple example. It's even simpler than a currency.
What?
This graph thing.
There's no transactions.
Exactly. Well, there are transactions in the Ethereum sense, but there aren't monetary transactions yet.
If you want to check if there are 2 hops, then it will be a bit harder.
Oh, you mean to check if if 2 people are 2 hops apart, right?
Build a decentralized graph.
No, it's just so there are pathfinding algorithms that are very good for this. Like what you want is you probably want some kind of variant of Floyd-Warshall, but the question is, do we want to do Floyd-Warshall on the blockchain? We probably don't. Yeah, actually no. I think you probably just want to do the algorithm and do it off chain. But then the other problem, yeah. Okay, so what you would do is you would loop through all of the storage keys in this in the graph. I'm not even sure if there's an API for that, but hopefully maybe there will be. If not, then what we can do is we can add a bit of a linked list here. So okay, let's add a linked list. So this is some pretty clever programming we're going to do here.
This EVM, it's 32 bytes arithmetic, right?
Mm-hmm.
Is it signed or unsigned?
There are opcodes for doing both,
so
actually.
Using -1, so is it?
There are opcodes for doing signed and unsigned. They just it's stored as unsigned, but the store protection makes it signed by default. Okay. Actually, no. All we want is we don't like the list. We just want to list the last pointer. Here we go. Okay, so now what we have is we have a nice list of like everyone who ever registered in this whole thing. Then from there, okay, do we really want to implement the Dijkstra's algorithm on the blockchain? Let's do it. Okay. Okay. Oh god, the Dijkstra's algorithm requires a priority queue. This is going to be painful. Okay, now this requires... Okay, this is supposed to be easy mode. Do we really want to do this? Like, I wrote a priority queue, but now we have to talk about importing and, like, creating contracts inside of contracts. We have to talk about init, so let's not do it.
But in Solidity, you will have like libraries and data structure.
Yeah, you'll have
Actually, right now it's very low level, like assembly.
Yeah, it's pretty low right. Exactly. Solidity is gonna have more like.
So if you would like to actually import some big bunch of code, how
like
would it work?
So.
Have to be verified. Distributed fashion.
Yeah, you'll have to verify. Like, the thing is that these operations are going to be very expensive, and you don't want to be doing complex computations on here. But the only thing you want to be doing is just very simple business logic checks like this, right? This is perfectly fine for every node on the blockchain to run, but the Dijkstra's algorithm not so much. So you want to do that off chain.
You just publish the proof you have done it.
Well, it's hard to publish a proof that you've implemented the Dijkstra's algorithm, at least until Skip comes along, but, well, I mean, until probably Skip is also going to be very inefficient on here. So anyway, let's not bother with this. We'll do a simpler thing. So, yeah, and like Serpent, I'm going to keep on upgrading that as well, so eventually I'm going to, like, yeah, the thing is here, right, is that the thing in Serpent, you can also have variables on the memory side, right? Like you could do things like, well, you could do that, right? But the problem is that right now in Serpent, the like an equivalent of that doesn't exist for storage yet. So that's probably something that I will figure out how to properly like.
So right now, maybe the best practice. The good practice is to use constant for all the opcodes.
Yeah. So yeah, the good practice is basically I just use constants. Like over here, I use constants and also like you notice the thing that the sort of programming thing I did is that in the crowdfunding project is that I put a big comment on top describing what the data model is. So
for this example, maybe I can define register equal 0 and check equal 1.
Yeah, you can do that, sure.
Is it possible to define actual constant or still variables?
These are, right now, they're variables. I'll probably add constants soon. So, fine, we'll do this. So, we have the HTML, now we want the JavaScript. So, for the JavaScript, you know what, just to make things simple, we're not going to do this whole updates thing, and we're not going to do the dots. Instead, all we're really going to do is we're just going to take this little if transact bit. From T, oh right, EL. I need an EL. EL is just a thing that I get. If you're ever not using jQuery, then this is something, or AngularJS or any of those. This just gives you a nice two-line alternative that gives you like literally over half the benefit. Replace the whole stupid document.getElement by ID thing, you know, with 2 letters. So eth.key. Then the value that we want is actually the value that we want is 0. 2. We don't know what our address is yet, so we'll keep this as crowdfund adder, but we'll change it to something graph adder. It's not even a real address. Data, what we're going to do is we're going to say 0 plus ETH.ASCII 0.pad32. Okay, now how did I do this here? There we go, it did it like this. Gas 6537. Actually, I'm going to be mean and make it. And the gas price, keep it the same. And that's it. I mean, technically, we have our Dapp, right? The only thing that we want to probably do is we probably want to have some way, also have some way of checking. So the way that we'll, I wonder if there's ETH.SHA-3 on here. Okay, checking is going to be hard. We will have SHA-3 in our API, so you will be able to do. Ideally you'd be able to do like client-side and server-side computations in the same language. So. Let me check what we already have. Okay, guess we don't have it. So you know what we're gonna do? We're gonna do a really lame trick. This is once again totally insecure. And we're just gonna store it in we're gonna store it in index say 5. So now what we want is we probably want some new fields for check 2. And we want another magic button. Yeehaw! So we'll just ask the blockchain to do a check for us. Basically, this is just a temporary thing before the APIs come into place. So now what we have is we'll also want to do initiate and check. So this by the way should be a function. And what other parameter do we need here? So what we're doing right now is we're basically sending a transaction to the blockchain to check whether two addresses are connected. So what else do we want? The other one, right, correct, the other one. Check 2, exactly. replace the comma with what? Correct. Yay, you're paying attention. Okay. 69533. Now, here, the other thing that we'll do though is we'll call update. And the way that we'll write update is, as it turns out, we are going to do this whole lame thing here after all.
Should we wait when we're writing this kind of app? Just like comparing to Bitcoin?
In most cases, 1 is going to be fine. If you want to write a secure financial app, then probably like 8 or 10.
Just like Bitcoin.
No, exactly. The faster block time does mean you want to go just a bit higher, like 8 or 10 instead of 6, but not 600. So, what are we going to do for update? What we're going to do is basically this get details thing, and get details is really just a matter of eth.state add, but all we really care about is just doing it once. So, what we're going to do here is we're going to do the exact same thing. We're going to check, has it updated yet? We're going to use this as a sort of thing that just... We're going to be lame again. Okay, yay, people are back, okay. So we're going to check the state app, we're going to check it to T, and we're going to update. And in the update function, what we're going to do is we're just going to repeatedly check this guy. Now, we have two choices. If T is not equal to ticker, then we do something. Otherwise, we do something else. So, which one of the two do we want to recurse? Which one of the two do we want to recurse on update inside? This one, the one where T is still the same, right? Yeah, over here, instead of doing and there we go. Actually, hold on. I think that's it, actually. So, just to go through everything again. So on our HTML, actually, you know what we'll do? We'll just go look at it here. So in our oh god, it's graph.js 27. I made a JavaScript error. Yay. Original POC 6 yes, I think requires me to reload. So we have a graph. So over here, you notice we have, yay, no bugs. So we have two boxes, right? We have a place to, register a connection and check from and check to, right? So Okay, this is a problem. I'm not even sure how to figure out what my address is, so it'll be kind of hard to check the second feature. Actually. By the way, does anyone else really hate how you have to do this instead of being able to just put console.log as a function? Okay, Ether get key is not a thing either. There we go, okay. Right, object.key, it's been a while. There we go. That gives you a bit more. Ether key does not even show up there. Here we go, that's my address, yay. Figure it out. I just need to get it out. Okay, still can't. There we go. I'm just gonna put this here just in case. And I'm gonna connect to 3. Start mining, connect to 3. Now you notice that I actually, I didn't make it up. I didn't make any kind of update mechanism. And what you see here is you see a block, the TX SHA is not null, so it contains the transaction. Check. Now I'm also gonna check these two.
When did you put
Right. Oh, right. That is something that I forgot to do. So let's do that now. So first step is Serpent compile. By the way, I'm using the POC6 version of Serpent. Be sure to use the correct version of Serpent. There are 2 branches. See this? Serpent code. A new transaction. Basically, I'm just doing hash bang hex and then putting the hex down. You want a bit more than that gas. And you just send. Miss is nice like that. Right, and there it gives you the address for the contract. So now, what we're going to do is we're going to replace the graph addr with something more reasonable. And we're just going to reload this whole thing. Right. So the other thing you might want to do sometimes is you might want to massively increase the amount of information you're getting. The benefit of that is that you now connect. And if it's all done correctly, you might be able to see the VM trace, or maybe not. Okay. So there is one approach that we can use to, there is one approach that we can use to sort of debug things at the low level and see what happens. So one approach is we take the details and we're gonna dump the state. So VM1, check the address. And it has, oh right, that's our address, never mind. The other address, the address that we really care about is this guy, the graph adder. So let's check it. See, and it's got a nice code hash to it now. But it's got no storage. Or at least the storage looks empty-ish to me. Oh, crud. It's still using... That explains it. It's still using an old version of the... Hold on. Do I actually say crowdfund that or anywhere? Oh dear God, I do. That's nice and simple.
This is the danger of using dynamic languages for real, for money.
Yeah.
For financial stuff.
Okay.
I think we need to have some short break because
soon. Yeah, there we go. I'm actually almost done.
Electricity sockets.
Right. Well, oh, I got 33 minutes left myself, so I'm fine. So I'll make sure that it happens in reasonable time. So TX SHA 5143, there we go, we got included. So now what we do is we check our address. Yeah.
It was all the way in
the we could probably fix this. You know, we could probably fix this just plain inside of here. So the person who's working on making really nice debugging tools is Gav. He's trying to create a really integrated environment where he can do debug every single piece of the code at the same time.
By the way, why working with list and not Alex 0?
Because oh god, this is being recorded. I do think the UI is better. Like, you know, with Alex 0, the problem is that the whole thing is just so big that you actually need to delete a few sections for it to even fit into your screen.
you get at least 2 screens to work with.
Yeah.
Which is fine.
If your screen doesn't relate, you cannot part of it.
Oh no. Oh god, I figured it out. We just have to put this out correctly. There we go. That's what we need. It's interesting hangout. Actually, we're not even going to bother with connecting. We're just going to check. And results 1. See, we're connected. Done. Ta-da! It worked. Okay.
No, it doesn't say anything. It can be by mistake. Can you use somebody else? Check negative example.
Error invalid integer. Ah, I see. See, the problem is that zero. Ooh. Actually, let me check. There's probably a quick fix. That's probably what it's doing.
Are there binaries for Windows for this time?
There should be. I believe there should be, yes.
You could post it later on the
Sure.
Hangout.
There we go. That's the fix, by the way. UN 0x plus b there. JavaScript is a magical language. People hate JavaScript. Actually, really kind of like it. The one big gripe I have about it is that it doesn't have big number support like Python does.
Yeah.
Like if it did, I'd like to use it for everything. Oh, and if it got rid of the curly braces and it replaced them with like indenting, and if it had nice standard libraries and it turned into Python basically. So. Oh, right. Okay, so what we're going to do is we're going to check the positive example first. We're going to start mining on it.
If it was a real blockchain, right, you wouldn't be able to fix the contract, right? So you need to have some kind of a way to...
That's exactly why debugging is so important.
So you would have to do it in a test one,
yes,
then upload it.
So positive case works, now let's try negative case. If this doesn't work, we'll just wrap it into try except, and we know that's gonna work. Come on, seeds. Will there be a new block before it gets to 55? I say yes. See? Ta-da! Okay. And it works. Yay. Alright. Yep, there's a lot of lag. Okay. So
now you can extend it for pay for friendship, like Facebook for.
Oh, you want me? Okay, here, I'll extend it to pay for friendship right now. Watch. How many seconds do you think this is going to take? Done.
So how much in Ether stand to redeem?
One.
One Ether?
Yeah. Watch this. Is that what you want?
Why did you do that?
Basically, anyone can set their price, and this is the price you have to pay to be my friend. What else do we want?
So now it's a time for break, I think.
Yes, it's definitely time for break. So, I mean, it's basically, I think I'd say the end of the showing part of this whole thing. And yeah, the last thing I'll do is I'll upload this to GitHub.
This is Emmett.
Oh.
It's like that thing you showed before.
Right.
So you're taking a break?
Yep. Taking a break.